Okay, let's spend a little time talking about how we analyze polynomial functions here in section 5.4. This is hopefully going to be a short little talk, and you'll be spending most of your time working on an activity, applying what you're hearing here and some of what you already learned back in the previous section. So, what we need to look at is really how do we get the shapes that we get in our graphs, and that comes a lot from the maximum and minimum, which you'll see highlighted here in that first sentence. That's what gives the shape. We've talked about end behavior already, what's going on at either end, but what's going on in the middle? That's where we're focusing now. Together, these points, these maximum and minimum, are known as local extrema. Extrema being a plural for extremes, or another way of saying extremes. And they also represent turning points for a graph. If you look at the two graphs that are shown here, you'll see there's a local minimum right here on this first graph at the top, and a local, or that's a local maximum, and then a local minimum over here on the right. And they're considered local because it's just right in this area. There's still more happening on the graph. The graph does go much higher, goes off to infinity over here on the right side, and this is local minimum here, just right in this area. That's the lowest point, but the graph overall does go lower. And also it's considered a local extrema because the graph changes direction. It goes from rising up to turning and going down and then going up again. Now if you look over here at the second graph, you'll notice that there are two local maximums or maxima and two local minima again. Now, polynomial functions that are of whatever degree, so we'll say degree n, they have at most n minus 1 turning points. So if it's a third degree function, so it's a cubic function, it has at most 2 turning points. It could have less, but that's the most that it will have. So our first example graph that's over here, it has 2 turning points. So that means degree would be 3, or if the degree was 3, then at most it would have 2 turning points. And that's where we also get the idea that the smallest degree or the least degree depends on what book you look at, who you're talking to, whether they use smallest degree or least degree of a function is the number of turning points plus 1. So that's why I looked at that first example and said, well, it's going to be a third degree. There's 2 turning points. 2 plus 1 is 3. Over here on the second example, there's 1, 2, 3, 4. 4 turning points. So the smallest degree, or the least degree, is going to be 5, because 4 plus 1 is 5. All right, now, we talked about this already, but it's worth mentioning again. Odd degree functions have only local extrema because their end behaviors go in opposite directions. Even degree functions will have at least one absolute maximum or minimum, and possibly other relative extrema. Now, previously it said local extrema. Here they're saying relative. Local and relative you can use interchangeably. You'll see, in fact, that they're both used here. On the activity you're going to do, I believe I use the term relative rather than local, but you can use either one. It does not matter. But there will be, with an even degree function, at least one absolute maximum or minimum, with some other ones possibly, but there's at least one absolute max or minimum because the end behaviors for the function go in the same direction. So, and you can have more than one if the graph has turning points with the same y value. So they may just bump along and stop at the same point and change direction at the same y value. They won't be exactly the same spot, it won't be the same coordinate, but you could have it happen at 2, 3, and then again at 5, 3, something like that. All right, lastly, you can find maximum and minimum points basically the same way you find zeros in a function when you're using your calculator. And eventually we will try to take a look at that with our calculators. But for now, we're really just looking and analyzing graphs and seeing what's happening there. Thank you.